Okay, year 10, so while I'm at soccer, what you'll be doing is dot plots and stem and leaf plots. And what they are is two tools that we can use to display data. So previously in 5B, you'll recall we looked at the column or bar chart, and we looked at the histogram. Okay, now remember this one here was for categorical data, and the histogram was for numerical data. Well, the first one we'll look at is the dot plot, and it's for categorical or numerical data. Now, it contains dots, and the dots are evenly spaced to reflect frequency. I'll explain this in a sec. The columns are evenly spaced and labelled. So here's an example of a dot plot from a further maths exam actually. And what you can see here is the development index for each country is a whole number between 0 and 100. We've got 28 countries in the dot plot. Okay, so we can see that one particular country had a developmental index of 70, then 73, 73, 73, 74, 74, etc., etc. So we can see that all 28 countries here have a dot next to their developmental index. So it's a bit like showing the frequency of these particular numbers. So let's construct a dot plot for some fictitious class data. So we've got our favourite colour here, and let's pretend that I surveyed the class and these were our favourite colours. So all we do is we draw up a line like so. Draw it straight. And then what we do is we put some notches that we're going to use to represent the colours. So we're going to put a notch there. And remember, they have to be evenly spaced. So there's green, there's red, there's pink, there's black, and there's blue. Okay, so could have spread it out a bit more, but it doesn't matter. Okay, so what I'm going to do is call this one G for green, R for red, P for pink, BL for black, and B for blue. Right, and we'll put our key over here. So G is green, R is red, P is pink, BL is black, and the last one, B is blue. You only really have to do this if you're only putting like a letter to represent the particular category. If you can fit the word green in there, just do that. Okay, now let's put the dots in. So green has a frequency of 5, so all we're going to do is put 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, roughly evenly spaced. Now red has got 2 dots, so we're going to go red is 1 dot, 2 dots, and you'll notice that it's roughly the same height as the green one. Alright, pink, we've got 1, 2, 3, then 8, 1, 2, 3, 4, 5, 6, 7, 8, and blue was 3, so 1, 2, 3. And we're going to put a heading 10 MGME favorite color. Right, so there's our dot plot. So it works well with numerical data, and it also works well with categorical data. Okay, so the other plot type that you'll look at today is what we call the stem and leaf plot, or just a stem plot. And what we're going to do is produce ordered stem and leaf plots. Okay, and the important thing to note is it's for numerical data. Okay, so we've got something called a stem, something called a leaf, and a key to explain how to use our plot. So here is an example of a stem and leaf plot, and we can see here that we've got the stems, which are 1, 2, 3, 4, and the leaves, which are these values here. So what we would do is we would stick the stem onto each of the leaves. So this is 10, this is 11. So all we're doing is we're taking the stem, just adding the leaf each time. So that's that one done. That's that one. We've got another 11, and we've got one with a leaf of 15. So 5. So that's 15, etc., etc. So this key down here just explains how to use the stem and leaf plot. All right. So let's just try putting one together. So we've got this data set here. Okay, so I find that the best way to produce an ordered stem and leaf plot is to actually use the calculator to order the data. So what we're going to do is, from the main screen here, we're going to go New Document, and we're going to add a list and spreadsheet. All right, so all you do is you type in your data, 53, 44, 35, 47, 51, whoops. Exciting video this. Almost there. Okay, so once you've got your set of data in, then all you do is you click on the A column. Okay, so you click on that. Oops. And then what we're going to do is go Menu, and there's an action that we're going to take, which is to sort. Okay, so Menu 1, 6. Okay, and we're going to sort ascending. That means smallest to largest. So let's hit OK. Alright, so now we can click up to the top, and we know that the data is in order. So we can see that the smallest number is 2, and the largest number is, well, smallest number is 22, largest number is 72. So let's set up our stems. So this is going to be our stem, and this is going to be our leaf. So the stem is the first digit, okay, or the leading digit of each of the numbers. So we can see here that the leading digit is 72. Let's go back to the first number, which was 22, and our stem is going to be 2. Okay, then we got 3, 4, 5, 6, and 7. Alright, so all we do now is we just go down on our calculators and put the leaf on. So that's 2 for 22. Now 3, so we got a 32, a 33, and a 35, and we don't put commas there. We just assume that the stem puts each of these, each leaf goes onto the stem. Alright, so I'll just scroll down into the 40s. Okay, so we've got 43, 44, and 47. So roughly underneath each of the top numbers there, just to keep things in order. Okay, now 5s, we've got what, 51, lots of them. So we've got 51, followed by 51, followed by 53, followed by 57, 59, I wonder if that's the last one. Yep. So now we're going into the 60s. Okay, so it's 62, 64, followed by another 64, 68, we've got a 70, so 7 with a 0, and 72. Okay, so we need to put a, a key. So you can pick any value in the data set or make up your own one, it doesn't really matter, but I'm going to pick the first one, which is 2. 2 means 22. Now that's important, because if this was 2.2, then 2 pipe 2 means 2.2 if that was the case, but it's not. Alright, now let's have a look at the shape of that data, and we can quickly see. So remember that there was 3 shapes that we can look at. Okay, so if our shape of the data is like this, okay, we call this approximately symmetrical. Okay, then what we've got is, that's a bad example. Let's let's try that again. Okay, so this one here, what we call this one here is a negative skew. Okay, so a negative skew is tail at the bottom. Okay, and this one here, if the shape looks like this, we call this a positive skew. Alright, so we can see here that the shape of our data is approximately symmetrical. So I only bring this up because some of the questions will ask you to describe the distributions. Okay, these diagrams here are also on your notes from 5B. Alright, so sometimes we want to compare two data sets, so we can compare them using what we call back-to-back stem and leaf plots, or back-to-back stem plots. Alright, so let's do this one here. Okay, so what we do is we've got the stems in the middle, and it doesn't really matter which employee you put on which side, but we'll put employee 1 on that side and employee 2 on this side. Alright, now again, I highly recommend you sort the data, so type it into your calculator. I'm going to pause the video while I do this because you don't need to sit through me doing that again. Okay, so we're back here and you can see that my column B and C in the calculator is full. So what I'm going to do is click on column B and go Menu, Actions, Sort. Sort column B by ascending order. Same for C. Menu, 1, 6. Okay, so let's check it. So 18 and 17, so we're going to start with a stem of 1 going through to a stem of 5. So here we go, 1, 2, 3, 4 and 5. Alright, what I'll do is I'll pop in employee 2's data first of all because that's the easiest. So we've got 17, followed by 17, followed by 20, followed by 28, followed by 29. Okay, 30, 32, 32, 37, 37. 40, 45, 46, 48, 49. I think that might be the last one. Yep. Okay. Now let's do employee 1, and this is the harder one to wrap your head around. So 18, what we've got to do, we know that the 1 is the stem, so the leaf goes here and the 8 goes there. Now I know that looks like 81, but we've got to read stem first and attach the leaf. Alright, so then we've got 19. Then we've got 20. We've got 21, 23. So hopefully you're getting the hang of it. 27, 35, 35, 36, 38, 39, we got 43, 45, 49, and 58. Alright, so find it much easier to do in the calculator rather than sort of trying to look through the list and get the smallest number and then the second smallest number, etc, etc. Alright, so let's put a key in. So 1, 7, I'm just using this one here, is 2 televisions sell the number of, so this is the number of televisions they sell over a 15-week period. So employee 1 sells like 28 over 15 each in that particular week. So 17 is 17 TVs sold. Alright, so again what we can do is have a look at the shape. Alright, so this one here, definitely has the stacking at the top end here. So if you tilt your head, you'll see here that, how can I draw this? Sort of that drawn on its side would look like that. So lots of high numbers relative to small numbers. So this is what we call a not positive skew, negative skew. And this one here, we can see that it is, we would say that this is approximmetrical. Alrighty, so your job now is to complete that exercise. Good luck.